Next, we are going to see what is the threat. So, and the types of threat. So, threat we have already seen a definition in the earlier slides. Threat is a set of circumstances that has the potential to cause harm to a system or a loss to a computing system. So, based on this, we are dividing threat into 4 kinds. The first one is interception, second one is interruption, third one is modification, and the fourth one is fabrication. So what is interception? So interception means that some unauthorized party has gained access to an assert. So example is illicit copying of a program or data files. What is interruption? Interruption, an assert of the system becomes lost or unavailable or unusable. So here an assert of a system will become lost or unavailable or unusable. That is an interruption. So malicious destruction of a hardware device or erasure of a program or a data file, or malfunctioning of an operating system, file manager, all these things, so that it cannot find a particular disk file. So all these things are kinds of interruption to a computing system. Next we see what's modification. So if an unauthorized party not only accesses but tampers the assert. So we earlier seen just accessing the assert, but here they are going to tamper the assert. That is called as modification. Example is someone might change the values in the database, alter a program so that it performs an additional computation, or modify data being transmitted electronically. So these are some of the examples of modification. And finally we see what is a fabrication. So it is an unauthorized party that might create a fabrication of counterfeit objects on a computing system. So example here is the intruder may insert spurious attacks to a network communication system or add records to the existing database. So this is an example of fabrication. Next we will see what is method, opportunity and motive. A malicious attacker must have 3 things. In short we call it as MOM, M-O-M, the method, opportunity and the motive. So what is method? So it is the skills, knowledge, tools and other things with which to be able to pull off an attack. So that particular person should have the skills, the knowledge, tools and the other concerned things which will actually help him to make an attack. So the knowledge of systems are widely available. So here if you want to learn the system, there are a lot of ways that you will learn the system and you try to accomplish the attack. Next is the opportunity. It is the time and the access to accomplish the attack. So here the systems available to the public are accessible to them. So you create an opportunity or you use an opportunity that is already being there. Next is motive, a reason to perform this attack on the system. It might be for a particular purpose or just it might be to prove that you are a good hacker. There are 2 types. So some places are what are called as the attractive targets. So some particular systems are very attractive to the attackers, or it's very appealing to the attackers. So what is the meaning of computer security? And before that we will see what are the security goals. So when we talk about the computer security, we mean that we are addressing 3 important aspects of any computer related system. confidentiality are the key to security. First one is confidentiality, next is integrity and availability. So you can mark this very important: confidentiality, integrity and availability. So what is confidentiality? The confidentiality ensures that computer related asserts are accessed by only the authorized parties. It is like reading, viewing, printing or even going there. So it concerns the secrecy of the file. So you should keep some information or some system confidential. This is not accessible by all. What is integrity? Integrity means that asserts can be modified only by the authorized parties or only in the authorized ways. So here we provide a means by which you modify the information or the system. Next is availability. So availability means that the asserts are accessible to authorized parties at appropriate time. For this reason, availability sometimes known by the software is given lapse. So here, whenever the authorized person allows, whenever the authorized person wants to access a particular computer system, he should be allowed to do that. If he is not able to access, then we can assure that there is something called as denial of service, which is again a threat to your computer or a system. So one of the challenges in building a secure system is finding the right balance among the goals and which often conflict. For example, it is easy to preserve a particular object's confidentiality in a secure system simply by preventing everyone by reading that object. However, the system is not secure because it does not meet the requirement of availability for proper access. So if you are going to make it more confidential, then availability becomes less. So it's a contradictory case here. So you have to design the system in a such a way that it should be available and also it should be accessible. Both these things should be taken into consideration. So in fact, these three characteristics can be independent, can overlap or even be mutually exclusive. It can be of three types. But these three should be combined to form the secure system. So what is confidentiality? So it's how do you ensure that? So ensuring confidentiality can be difficult. That's obvious. For example, who determines which people or systems are authorized to access the current system, which is the most difficult task. You should mark people who can access the system and unmark the people who cannot access the system. By accessing data, do we mean that an authorized party can access a single bit, the whole collection, pieces of the context? That's another question. So when you allow an access, whether you can access only a bit for a collection, or the pieces of data, or it might be the entire information. Can someone who is authorized disclose the data to the other parties? So that's another issue. Can a person who knows the information disclose the information? So all these things should be taken into consideration when you looking for this confidentiality. So we understand confidentiality well because we can relate computing examples to those of the reserving confidentiality in real world. So we can bring in some real world examples into your system. So again, integrity is much harder to pin down. So integrity means different things in different contexts. So precise, unmodified, modified only in uncertain ways, modified only by the authorized people, modified only by authorized processes, consistent and meaningful and useful. So it should be precise. When you do a modification, it should be precise. It can be left unmodified, modified only in acceptable ways, and modified by only the authorized people. So these are all considerations you take, and modify only by the authorized processes, consistent and meaningful and usable. So all these things should be taken into consideration before you actually look for the integrity in a system. So integrity can be enforced in much the way same as the confidentiality by rigorous control of who or what can access its resources in what way. So you have to control who or what accesses a particular system. Next is is the availability. So availability applies both to data and to services. That is to information and to information processing. We say that data item, the service or the system is available. So availability should be ensured for the persons who are authorized. If there is a timely response to a request, then we say that the system is available. If the resources are allotted fairly so that the requesters are not favored over others, then we say the system is available. The service of the system involved follows the philosophy of fault tolerance, whereby hardware or software faults lead to graceful cessation of service or to workarounds rather than to crashes and abort loss of information. So here, when you have a fault in the system, it should go for graceful termination of the service, or it should make some alternates. Then we say that the system is available. The service of system can be used easily and in a way it was intended to be used for. So when you design a system, it should be in a way that it should be used easily, and it should be used in the used in such a way that it should fulfill the purpose. And concurrency is controlled, that is simultaneous access, deadlock management, and exclusive accesses are support as required. So here the concurrency should be taken into consideration.